Live. So we are going to be talking fire pumps, fire pump requirements today. We got Larry Ayer, Viscom Electric, and don't tell me, M2E Engineering, right?
You
E
screwed
to
it up
M, E
already.
to M.
No, you screwed it up again. E2M engineering. You're
E2M.
close.
I was close. E to M Engineering. Yeah.
Yeah. Three's a
Beautiful.
charm.
That's right. So we got about 24 people out there. I see we got Russ Safried in the house, which is a good thing. We have Ellie, I think it's Eiley Markovic. Awesome. And Felix Sandoval. So we are reaching out there pretty far. So we've got a good registration for this session. I'm going to shut off the scroll. We got a good registration for the session. Thanks for everybody for joining us. And hopefully we will all share our information on fire pumps and learn something from today's session. So looking forward to a great discussion. And it is 5:00 p.m. as promised. 5 o'clock Thursday, technical Thursday, whatever you want to call it. And we got Larry Ayer. Larry, why don't you just introduce yourself to everybody real quick?
No problem. My name is Larry Ayer. I am out of Cincinnati, Ohio. I have an electrical contracting company and an engineering company as well. So I do both, so I kind of know both sides of the fence. And a part of that, I am registered in approximately 8 to 9 states. And I've been up to New Jersey a couple times here recently, do some engineering. And so I get around to see some different things. Do a lot, mostly in commercial, mostly commercial, industrial contracting. And I've been able to be on NFPA 70E. So I participate a lot in some of the NFPA committees. I'm on code making panel 13, which deals with batteries, fire pumps, emergency systems. And I also currently am the chair of the NEC Correlating Committee.
Ooh, big man on campus. All right, Larry. So I've got my 2020 code book. I know you got yours. I'm sure you do. And my name's Thomas Dimitrovich. I think everybody who's tuning into this probably has seen, knows who I am. So I appreciate everybody for dialing in. And hopefully we've got some new people to the channel. Remember to subscribe to the channel. I'm gonna be doing this every Thursday. So we got great people like Larry and others. I sit on code making panels 10 and 2. So I have 2 and 10, and then we got Steve Froming in the house as well, out there in YouTube land. So good to see you, Mr. Froming. But so yeah, so I obviously I work for Eaton, and we're going to talk about fire pumps, and I'm going to learn something as well. And I told Larry, I said, I'm not the sharpest knife in the drawer, but I know that we can figure this out together.
And we have, since Steve Froming is also on panel 13 that deals with fire pumps, he can correct me wherever I'm wrong.
Absolutely.
So that works out well.
Absolutely. So thanks for joining us, Steve, Mr. Froming. Please don't forget to use the chat. So everybody who is out there who has questions, use the chat. I will be monitoring that as Larry and I have a discussion around fire pumps. I'll be peeking at the chats, so throw your questions there. Steve Froming and others who may be on board who are very familiar with fire pumps, please chime in with your experiences. That's how we learn. That's how we roll. All right, Larry, you ready, brother?
I think so.
Me too. So I threw this slide in as a sort of an overview. Larry and I were talking about this from a perspective of before we actually get into the details, it's really important to understand what is it that we're talking about? Where does it play in the role of fire suppression? Basically, that's what we're dealing with. The topic that we're going to be hitting is that big red box in the middle, which is around fire pumps and the fire pump system, which takes the water from a source. We're not going to get into the water source. And it supplies the pressure, right, Larry? The important part is the pressure that is being supplied to supply the water through the sprinkler system in the structure.
Yeah, that's correct. And what happens is, we've done this on several projects. You basically go out and try to, a lot of people want to make sure that you have a sufficient pressure to get to the last sprinkler in the loop or the branch. And I think typically, and it depends. Typically, I see that I think sometimes you need 7 psi to get to that to that last sprinkler. So what you do is you do flow tests out there, and you run these flow tests to make sure that, you look at the residual pressure where there is, no water flowing, and then you simulate water flowing through the fire hydrant, and you draw a couple lines together, and then you look to make sure, okay, what happens if I have sprinklers go off? What happens if I need 250 gallons per minute from a fire hose and from a sprinkler going off? And so then you estimate what the pressure would be, and if the pressure is too low, you need to supplement that with some type of fire pump or things of that nature.
Perfect. All right. And I didn't know that that it was the 7 psi. That's an interesting comment.
But it also depends too, and sometimes on maybe if you're in a depends on the sprinkler head too. Sometimes you might need greater psi depending on how big an area. And typically in most smaller sprinkler systems, it's about 7 psi.
All right. Well, that's good to know. Okay, so I'm just moving my windows around, so bear with me, Larry. I know you're like, what the heck are you doing? All right, so basically we're talking about that red box in the middle. We're going to hit fire pumps. Now, I think it's really interesting, Larry, in my perspective, from a safety perspective, I'm always worried about protecting motors, protecting conductors, protecting transformers. I would say this is probably the only part of the power distribution system that we want to run until it fails, no matter what, right?
That's correct. You want to make sure that one of the concerns is we want to make sure that we keep those fire pumps going and keep the sprinklers and the water trying to put out the fire. So we want to make sure that when all else fails, even if we have locked rotor conditions or whatever, we want to make sure that we can try to keep that pump started and going and eliminate the fire hazard.
Yep. And so the continuous uninterrupted operation is primary. They're not so much as worried. Now, from a safety perspective, there's provisions, and we'll talk about the protection of the conductors, because you want to keep the fire pump system as simple as possible, right? Because simplicity breeds reliability in some cases. Arguably, we could probably debate that topic all day, but you want to keep things simple. So there are things that we do, because you're probably coming right off the service. There's things like fire ratings, which we'll talk about. There's special precautions you have to take with regard to those conductors. But when it comes to, like you said, if there's a locked rotor, or if there is, something going on in that motor, it's like, I want that puppy to just keep going until I could burn up the wires. I could do other dangerous things, but the electrical safety aspect, we're not making steps for the electrical workers and things like that, right? There's not, like, we're not putting ground fault in there.
That's correct. So we want to make sure that the breaker's sized high enough for the lock rotor. We want to make sure that we have wires that are protected for 2 hours in there. So we want to do whatever we can to give that fire pump enough time to push that water out to put the fire out.
Yep. So from an electrical worker perspective, there's probably a lot more precaution, a lot more. Your alarms should be going off if somebody says, I need you to do some work on a fire pump system, right?
Right. We need to make sure we have alarms in certain contexts and things that we find through NFPA 20 and 695. We got to make sure that we hook those alarms up so we know if someone happens to maintain that fire pump, they turn it off. So, or if the power doesn't turn on, we want to notify people right away that there's something going wrong.
Yep. All right. So and I think that's the primary gist of our discussion on that at that point. This is sort of the general parts and pieces. So we were also talking about, if you think about the overall system, and I made a comment on from a simplicity perspective, there's not that many parts and pieces to this puzzle, and probably the shorter the list of components, the more reliable and probably the lower cost of the installation would be, right?
Well, I think that the hooking up fire pumps and things like that, it's probably a pretty expensive proposition to get all these things and put all these things in, especially when you try to make sure you got 2 hour rating and you got fire pump controllers and jockey pump controllers. So there's a lot that goes into it, because of course this is the main thing that you're using to protect the building. So yeah, it's probably costly, but we want to try to, in this presentation, we kind of want to break it down into kind of simplistic pieces so everybody kind of understands the gist of it.
Gotcha. Gotcha. So you have obviously you have the power supply, which you could be a service or a generator. And we're going to get into those details. You have the pump itself, the jockey pump, and we're going to talk about that. And then you have the controllers, whether they have a fire pump controller and the jockey pump controller. I don't know if they can, I'm not sure if they're probably both of those are in separate components, but at least that's the way I've seen it. You have the disconnect, obviously, and some of that can be combined into the pump controllers.
Right. It depends a lot on how you wire it, and whether you wire it and tap off the service, whether you go straight from the service into it. So there's a lot of different ways you can do it. And, some people might only wire a couple of these in their lifetime. And, some people, this might be, just old hat doing these things all the time. So, I know that we did one the other day, and, some of the guys, some of my project managers that were doing it, they said, I haven't done one of these in a while. And so, can you help brush me up on this? Because, there are a lot of rules that you have to follow, and it spans across a lot of different standards. And so if, sometimes when you don't look across these standards much, you might miss something. So,
yep.
So there's little pieces in all these different NFPA standards that people should be aware of.
Yep. So we have a comment saying what's considered a reliable service, and we are definitely going to get to that because that's going to be early in our discussion.
Absolutely.
Absolutely. So there's your fire pump. This is just a general picture, and there's a lot of obviously a lot of water pipes, and this is an electric driven fire pump in this example here. But then you have the diesel engine driven fire pumps, which I noticed, Larry, this one is located indoors, and there's probably, you've got a diesel engine, you're going to have fumes you have to deal with to get that out. I guess that's what that big chute is going up the top there. But location of a diesel engine driven fire pump is probably challenging, right?
It can be challenging. So, some people put these in parking garages. Some people locate these outside. Sometimes, maybe you don't have the property or real estate to put them outside. And so these things it depends on what you're trying to achieve. Where the service is located, where the water comes into the building. So there's a lot of variables that go into making these decisions.
Absolutely. So another good image. I like this one here because it shows the fire pump, but it also shows that jockey pump. And the jockey pump you pointed out, like we were looking on one other image, and I was thinking, well, this might be the jockey pump, but I don't think that the jockey pump was in that other picture. This one's very clear because the jockey pump really, how about you describe that purpose of that jockey pump? It's about pressure, right?
Right. And I think that, you always want to maintain the pressure in the pipe. And, part of the thing is you want to maintain the pressure so that way when the fire pump, the fire pump doesn't have to do it, right? The fire pump is typically a much larger motor. The jockey pump might be 1 to 5 horsepower, where the fire pump might be 75, 100 horsepower or greater, stuff like that. And so you want to make sure that, the fire pump, you don't want that to kick on all the time to maintain the pressure. So that's what the jockey pump is doing. And I think the jockey pump is also maintaining the pressure. So that way, if you would happen to have a drop in pressure in the pipe, that will be able to send signals to the controller to let the controller, know that you might have a leak, or that you actually a sprinkler opened up and you need to do something. And then the fire pump and the controller needs to alarm people.
Excellent. Felix Sandoval is asking about the requirements for a fire pump motor. Can any motor be used to drive a fire pump? That's a good question. That motor is probably I don't know what the standard is that it's listed to, but I'm sure that motor is listed specifically for use in that fire pump system.
That's a good question. I do not know the answer. Typically a lot of these things I think are Class B motors. I know that they have to be listed, and they have to be called on to, be able to be a little more probably sturdier than your standard motor. So it can withstand some severe conditions when it's trying to operate.
Yeah, so I'm looking. It says the standard for fire pump motors is UL 1000 and hold on. Added here. Standard 1004. So there is a specific standard for fire pump motors, and that is UL standard 1004. Now I don't have a copy of that. I can't tell you some of the specific requirements around fire pump motors. I'm sure there's probably special labeling requirements. There might be other requirements from a performance perspective. To your point, Larry, if you think about a motor, and when I pick a motor for a specific application, I'm looking at the design types because I want to know when I hit the peak, my torque and all of that good stuff. So this is a specific load from a fire pump perspective. They know that you're going to be pushing water, or they know the head and all that other good stuff that you're going to have to be worried about. They know the load, the profile, like you said about the design types for the motors and whatnot. So there's probably in UL 1004 specific requirements that address just the fire pump application, because you know what the load is that you're turning in that case specifically.
I would assume you're correct. Yeah, I do not know from my experience what that type of motor would be.
Yeah, and I don't have a copy of that standard, but that's Felix. Good question. Don Ganir says he's done a couple with both electric and diesel fire pumps in the same pump house building. Can't really put one outside up here where it gets cold. So I guess, yeah, that's the other condition Don pointed out is, the environmental conditions that you're putting this motor into now probably makes a difference as well. I mean, if it's going to get cold, if it's going to freeze, and you've got water and all that other good stuff that you're worried about, there's all those environmental conditions you got to think about.
Oh yeah, I mean, just like, I mean, it's somewhat similar to a generator. I mean, you put a generator, you can't really, it's tough to put a pump outside because you got the water out there and, for freeze protection and things like that. But, also too, when you put generators outside in colder temperatures, you got to worry about starting and things like that. So there's a lot of issues, and you got to worry about the environmental concerns and a lot of electrical things that you put in.
Mm-hmm. And if you think about that diesel generator, if you put it inside, you're going to keep it protected and all that good stuff. And yeah, you have to worry about the exhaust and whatnot. But we've established that thing's purpose is to get water to a fire. So regardless of other issues that you might be facing with regard to from a safety perspective, all that other good stuff. So this is a good diagram. Why don't you speak to this one?
Well, this was just kind of to talk about, we talked about the fire pump and the jockey pump, that typically the fire pump is your lifeblood right there. That this is what this whole course is really about. You take your water source, you have a pump there, the fire pump that pushes the water through the building. Of course, the higher you got to push the water through maybe a high-rise building, the more you have to be concerned with bigger pump. But you also have a jockey pump that is typically needed. That it's a smaller water line, and you kind of see that in parallel, and that's there to maintain pressure in the system. And so you also have the controllers that whether it's a fire pump and a jockey pump controller, those things there sense pressure and tell those two pumps on how to operate and how to work together and how to send alarms back to the fire alarm system.
All right. So Felix has a good question. He says, is it required that the jockey pump be in the same feeder as the fire pump? And do we think that's a good idea? So you think about from an electrical worker, we have a serviceable piece of equipment, and you want the receptacle fed from a different feed branch circuit so that it's powered up while you power something else down. This speaks to reliability. What do you think about that?
That's a good question. What sometimes you see is I've seen jockey pumps that have tapped off feeders from the actual fire pump feeder. You're allowed to do that. I've seen fire pumps fed out of a separate panel. I've seen fire pumps fed out of just a generator backed up panel. So I've seen it in various different ways. There's really nothing in the code that says it has to be on the same feeder.
Yep. And if you think about it, that feeder, and we're going to talk about the reliable power source and how we size everything and how we protect everything. So that feeder, if that feeder goes down, that means you lost your fire pump. You lost your jockey pump too, but you didn't have one, you're not going to have the other.
Right. And, basically the bottom line is the jockey pump's there just to maintain pressure. So really, when you lose power, the main component is, once that pressure is lost, the fire pump takes over. And so that's where you really want to have that backup generator and all the extra components to have the 2-hour rating and things of that nature.
Yep. All right. So let's hit the next one. So this is your, so we talked about the jockey pumps, we talked about the flow and all this. Now you've got your fire pump controllers and your fire pump transfer switches.
Yeah, and sometimes those are combined, sometimes those are separate. Those are installed in a variety of different ways.
Yep. L.A. Markovic asks, is the jockey pump sometimes called the booster pump?
I think so, but I think it's more or less called the jockey pump. I think that's just the jargon in the fire pump industry. I think it's well known. When you say booster pump, I think you start to lose what the real intent of it is for the maintenance of the pressure. So I think if you're probably in the fire pump industry, okay, they probably consider that a booster pump, but as well. But if you're just a person that's just new to the fire industry or fire pump, I think the jockey pump is probably a better jargon.
Yep. Gotcha. Good questions. Yeah, I told you.
That's not even. I've seen people not even back those up by generators. So there's not. You don't have to put 2-hour rating on those. So it's not really. It's just to maintain pressure and things of that nature.
If that jockey pump's not working, that doesn't mean that your fire pump is not going to work, is what your point is.
Correct.
Yeah. All right. That's good. That's a good point too. So these are our topics. We're going to hit the standards. We're going to cover the power source for power pumps. We're going to talk about the connection, the disconnecting means, overcurrent protective devices, the feeder and service conductors, the power wiring, the transfer switches. And I think when we get into the voltage drop, Larry, correct me if I'm wrong, but we're getting into examples, different types of examples and situations, application type of issues. Mr. Abbasi, I know, Mather, we were talking about you earlier. We said, boy, Mather Abbasi's going to be on there. He's probably forgotten more about fire pumps. So that's a good thing. I appreciate you being here, Mather. He says they've moved away from tapping the fire pump circuit since it is very hard to comply with the tap rules. Good point. Fire pump overcurrent protective device is 6 times the current or equal to locked rotor current. So that's a good point.
Yeah. And I don't see many tapping the conductor. I think, like Mather says, I mean, let's say you have a 200 amp feeder for a fire pump, and then you're trying to feed maybe a 20 amp circuit to a jockey pump. So, there is that code rule. I mean, you're trying to do, you can do a 10-foot or 25-foot tap rule and things like that, but it is kind of difficult, and it's much easier just to feed it with a branch circuit from somewhere else.
Yeah. All right. And then Chris and Misty Valtiera says, can you answer why the controller cabinet is only required to be a minimum NEMA 2? I don't know. Is that a requirement?
I think that might be a requirement in NFPA 20. It's not. I don't think it's listed in NFPA 70 on Article 695. And I'm not sure with that one.
Me neither. I would think that, well, I mean, it's type 2 is for indoor use, right? So that's a good question. I'm gonna have to do some research on that one. A type 2 enclosure is constructed for indoor use to provide a degree of protection to personnel against access to hazardous parts, to provide a degree of protection of the equipment inside the enclosure against ingress of solid foreign objects, falling dirt, and to provide a degree of protection with respect to harmful effects on the equipment due to the ingress of water. Now, a type 1 is for indoor use to provide a degree of protection for personnel against access to hazardous parts. So I think what you're getting in the part 2, type 2 NEMA enclosures is the ingress of solids and foreign objects. So they're probably protecting the electronics and whatnot more so than a type 1. But, when you get into type 3, now you're getting into windblown dust and things of that nature, which, that's, and rain and sleet and snow. So I wouldn't expect, because these things are, I mean, if you put it outdoors, if you did, then it would have to be listed for that application. But if it's indoors, I think what they're probably saying, and I don't know where that requirement is, but they're probably just telling you can't use a type 1, that you have to use a type 2 for ingress of solid foreign objects like falling dirt and things of that nature.
Well, I would think that when, this is my guess at it, but I would think that, a lot of times you see these enclosures in the basements. You see them in these fire pump rooms that maybe don't get much maintenance. There's a lot of dirt buildup. Maybe you have the situation where when the fire pump is called on, you want to make sure that this fire pump operates in any cost. So you might have putting this pressure on the fire pump. You might have a leak in the room. So you probably want that NEMA 2 enclosure. You want that enclosure to probably be a little bit more beefy than your standard NEMA 1 enclosure. So that's what I would think.
Yeah, and then Chris says no concerns about a burst pipe. So I think he's thinking, could this be a wet location if you have a burst pipe? And I don't think we plan for a burst pipe or things of that nature. Because if you lose the integrity of that, that's a whole nother problem on your hands. You can't. We don't design things for a failure of a water pipe in your fire pump system. So
yeah, and a lot of times these fire pumps, they sit in these fire pump rooms. They sit down there for 15, 20 years without not really being operational. And so you want to make sure that you have it in a decent environment. You try to keep any foreign parts out of there, any foreign dirt and debris, and so you want to make sure that over time, when it's called upon, it's ready to go.
Yeah. And Felix pointed out, he's like, is that fire pump, a jockey pump room, considered a wet location? I wouldn't consider it a wet location. Just because you have water pipes there, I would say that is not a wet location.
Correct. Yeah. I would not consider it a wet location.
So Brian Rock is saying that the type 2 enclosure, and I got to look at this. Look at this. And to provide a degree of protection with respect to harmful effects on the equipment due to ingress of water, dripping, and light splashing. So a type 2 enclosure gives you, it's not meant for outdoors like you would have in a type 3, but there is dripping and light splashing. So that might be another reason why you have a type 2 minimum. So good feedback, Brian. I appreciate that feedback. Yep. And Bruce says it better not be a wet location. The firemen they'll hate you for it, right? There was another question in here too. I don't want to miss. Felix said I already answered. Oh, installations with more than one fire pump require separate fire pump controllers, and that's a question mark. Do they require that? So can you have more than one fire pump off of one fire pump controller? Do you know that answer?
I would assume that you have to have two separate ones. I've done a couple projects where we've had two fire pumps for buildings, and we've had to have two separate controllers.
Excellent. All right. All right, so that's the sort of the overview, and we're getting some really good questions, and we haven't even really gotten into the meat yet, which is really cool. So these are the standards, right? So you got 20, 695, that's out of the National Electrical Code, 13 and 25.
Yeah, and I think too what's neat about what NFPA is doing, NFPA has a new product, which it's more of an electronic product that allows people to search across various standards. And so like if you wanted to, the way that NFPA is trying to do it is if you wanted to design a fire pump and you go into this new product, it's called NFPA Link, you'll be able to look up and type that in that I want to look at fire pump installations, and it'll pull up NFPA 20, NFPA 70, Article 695, 13, and things like that. And it'll give the user, when they install those things and design them, all the information at their fingertips. So I think that, when people think of fire pumps in the electrical industry, they think of Article 695. I really think that people need to understand NFPA 20. There's a lot of good material in NFPA 20. That is where a lot of the material from 695 comes from. And to be honest, I think sometimes the NFPA 20 is organized in a better fashion than 695.
Yeah, you were saying that. And you know what? The more I get familiar with NFPA 20, I would tend to agree. And I think some of the issues, I think the information is there. It's just the organization, right?
Yeah, I think it's in a better format, and everything's broken down. I think sometimes when you get to 695, it might skip over some parts, and you kind of got to look for it a little harder.
Yep. And then, Al Teresi noted that in 110.28, which talks about enclosure types, it says in there, that portable power distribution equipment, termination box, general purpose transformers, fire pump controllers, fire pump motors, motor controllers rated not over 1,000 volts nominal intended for such locations shall be marked with an enclosure type. So the National Electrical Code seems that it tells you need to mark the enclosure type, but I don't believe, and I can't find anything in the NEC that says it has to be a minimum of a NEMA type 2, unless somebody out there knows a little bit better than I do. But I don't see that, and I'll keep looking as we go through this, because that's an interesting point from a NEMA type 2 perspective. That might be in 20. So what is the NFPA 13? That is that's the sprinkler system, right?
Correct. NFPA 13 gives you all the rules necessary for designing and sizing a sprinkler system. Whether you're in ordinary or light hazard location. So it kind of gives you more of a feel for what you need to do for sprinklers. And NFPA 25 is the maintenance standard. It tells you how to maintain sprinklers and things of that nature, I think.
So Gustavo, yeah, you're right. It's testing and maintenance of water-based fire protection system. Now, Gustavo asked a question earlier, NFPA 13 versus FM Global. What is the middle point for safety, electrical work, and inspection? So I think, Gustavo, you were thinking of NFPA 25, because I would assume, because that's the standard for inspection and testing and maintenance. So in my opinion, I think that when you're working on a fire pump, because of how we design fire pumps, you're not allowed to have GFPE. You're not allowed to have these arc reduction technologies and things like that, because they're afraid of nuisance tripping or unwanted tripping. I think that that the electrical worker is in a difficult position there, that to establish an electrically safe work condition, you would have to go through a process to safely work if you're going to expose any energized parts in those applications. It's just I've never worked personally on those. I don't know if anybody out there has personally worked. I've done I mean, maintenance is one thing, keeping things clean and things like that. But when you start exposing energized conductors, where you're exposing yourself to shock and arc flash hazards, that's a different scenario. That if you are designing the system with the instantaneous way up there for locked rotor amps and whatnot, you're definitely not going to respond to arcing currents. So you're going to have high incident energy on these systems. And from a shock perspective, shock is shock. So, and shutting it down means you're exposing the facility to if they have a fire, then you're not going to be able to respond quickly, right?
That's correct.
Yeah. So there's some unique situations in regard to that slide. 695. So you have, 695 is laid out, like you said, Larry. I mean, it probably needs some love. It is past chapter 4, so it probably doesn't get as much attention as it probably deserves. But you can't forget about chapters 1 through 4, right? So you still have to follow 1 through 4 for conductor protection and all that other good stuff. It does amend 240 and 430, but 430 on that. On the Jockey pump, you're going to protect that based on 430, right?
That's correct. Yep. And so what you have to look at is, typically the code, 1 through 4 are the key, right? So 1 through 4 tell you how to size wires, how to protect wires, and overcurrent devices, when you need GFCI and things like that. And when you get up to 695, fire pumps are special equipment. They modify 1 through 4. We do not. It's just like motors. We do not protect fire pumps at fire pump conductors at the ampacity that you typically would think of in Article 240. And so we do some different things up there. We're not required to have ground fault protection on these circuits. So we need to modify those things. And that's why when you put the slide up there, that 695 is going to amend the requirements in chapters 1 through 4.
Yeah. So to answer Sal Ramirez's question, Salvador, I apologize if I shorten your name, but Salvador's question about the jockey pump, it's for Article 430. And then the controller for that, basically, the controller is going to provide the protection and whatnot. So that's all going to be sized and applied based on 430. Now, if you have a transformer in this circuit, and we're going to talk about transformers, you will be supplementing and possibly amending the requirements in 450, right?
That's correct, because a lot of times you need primary and secondary overcurrent protection, but we don't want to. We want to limit the number of disconnects we put in the fire pump system, and so that's why we amend that article. And one of the other things that you want to talk about is when you talk about the question is what article covers jockey pumps. When you look at 695 doesn't really mention jockey pumps. They basically refer to them as fire pump accessory equipment. So they use a different terminology than that.
Okay, so you're not going to find the term jockey pump in 695.
Correct. Now, someone's going to go look and they're going to find it once. But when they talk about when they talk about feeders, they do talk about when you size things, they talk about fire pump accessory equipment.
Now you are on the record as there's no jockey pump in there. I'm just saying, and this is recorded.
All right. I'm sure Brian Rock will go look. And he'll let us.
Yep. Beautiful. Awesome. All right. Good discussion. And then you have, so that's the other thing is, you said, this says Article 700. So we know Article 700 is life safety system. And I would assume that this would be, I would almost assume that this would be a part of the Article 700 system, but it's not. It's got its own article. But Article 700 is not modified by 695, right?
That's correct.
Don Ganir says he thinks twice in the scope and in the feeder section. Mohammed says it's being recorded, so be careful. Commit to nothing. And now we're both checking. We're going to check the scope of 695.
Well, you know what? And now that he mentioned, we'll have to change that. We'll have to get rid of it because, when you put that in the scope, it's hard to, if we're going to, this is another thing with the NEC. If you're going to put jockey pumps in there, then you really need to refer to other equipment and jockey pumps so people are consistent and they know what to do.
Yep. And this really gets into this. This is a great lead-in discussion because we're going to talk about what is covered and what is not covered. And what it says in 695.1b, what's not covered is the installation of pressure maintenance, jockey, or makeup pumps. So it could be, and Ali Markovic noted that you'll probably hear people call this a pressure maintenance pump, and if they say that, it's a jockey pump, which in some parts of the world they might call it to someone earlier noted a booster pump, right?
Correct.
So sometimes the slang terms out there can hurt you. So this is what's covered by 695: electric power sources, which we're going to talk about. Power supply wiring, obviously you got to get power down to the pump, and then any of the switching and control, and I would say overcurrent protection is in there too, right?
Yes.
Yep. So, and we don't define, okay, yeah, perfect. And then what's not covered is system performance, which is NFPA 20. Now hold on. So I guess that's why when we go into the understanding what is a reliable source, what is not a reliable source, that would be a performance type of thing, right?
That's correct.
Right.
So when we talk about those things, NFPA, and you have to look at some of those things because some of those are an annex material, but some of the things about reliable systems they're not. You don't really find those in NFPA 70, Article 695. You find those more in other documents of NFPA.
Yeah, and it's important to remember that the National Electrical Code is an installation requirement, and then 20 would be the performance requirements. So similar to other documents that have similar relationships like that. So we already talked about maintenance is 25, 20 is acceptance testing is in NFPA 20 as well. So that's interesting that your acceptance testing is in there. We don't have any acceptance testing or performance requirements or maintenance. Do we have maintenance in 695 at all?
I do not think so.
No, I mean, we have it in Article 700, but not in 695. Jockey pumps, Article 430. So we talked about that. And the alarm system is NFPA 72, which we did not put on, I don't think, on that earlier slide. So NFPA 72 is in there as well from an alarming perspective. Richard Curran, we recently had experience with concerns about a Jockey pump. A review proved it's not included with fire pump requirements. Perfect. So Richard is just confirming that from an inspections perspective. There it is, buddy. NFPA 20, the document that you love so well, that you think is so much organized, right?
I do. I do. I think that if you, most of the things you look at NFPA 20, if you just look at chapter 9 and 10, it really provides a good foundation in an organized fashion of fire pump requirements. You will not find things about protection of feeders, sizing of feeders, and things like that. That's all in 695. But I would encourage people to kind of look at that and just kind of get a feel for how it's laid out and what's contained in those two chapters.
Yeah, chapter 9 and chapter 10, electric drive for pumps and electric drive. So, and I think in 20, you would have information about the water supply and all this other good stuff that we, from an electrical perspective, we might not worry about, but from a overall design perspective and picking the pumps and whatnot, you're going to be if you're into fire pumps, you're going to probably be heavily ingrained in NFPA 20, I would assume.
Yes, I would assume so, because I think chapter 10 gives you a little more detail on transfer switches and things of that nature.
Excellent.
And people like, and we'll talk about reliability, but I think chapter 9 gives you a little more flavor about what they consider reliable. So I think there's some really good stuff in there that people should look at.
Cool. And we're gonna bounce around in 9 and share some of that with everybody. So I love 913 just says, hey, you got to comply with the installation requirements, right? Because that's 695.
Right, and so when you begin looking at NFPA 20, there's some general requirements in there, and that first section 9.1, and I kind of paraphrase some of these things, but I paraphrase them just to kind of give you the gist of what they're trying to talk about. You must comply with 695 because again, that tells you how to wire things, feeders, and things of that nature, listing requirements. You got 9.1.5. That's one of the keys, right? We need to have power supply shall have the capacity to run the fire pump on a continuous basis. You must comply with the voltage drop in section 9.4. You can't use phase converters, and you can't use ground fault and arc fault circuit interrupter protection. Now, me and you had the discussion. Well, where would you put arc fault interrupter protection? Maybe that's in a Jockey type setup or things like that. Maybe you talked about arc fault maintenance switches and things like of that nature. So, this gives you the general requirements of when you do this. They're telling you what not to do in a general fashion.
Right.
So, but some of these things again are covered in 695 and are duplicated.
Yeah, and my comment was like ground fault. I mean, ground fault. Just saying the word ground fault, you're not saying ground fault for protection of equipment at 1,000 amps and above. You're not talking ground fault protection of equipment at 30 milliamps. You're not talking about ground fault circuit interrupters. When you just say ground fault in general, that's pretty comprehensive. And an arc fault, I mean, is that an AFCI technology? Is that an arc reduction technology? Is that like an arc quenching switchgear perspective? There's a lot of, and I think in my humble opinion, I think that because of all the advancements in arc reduction technologies, this probably deserves another look, because you probably can increase the reliability of your system if you can reduce the amount of damage that happens that equipment should a fault occur inside wherever, but that's neither here nor there.
That sounds like that's coming from a guy that makes arc fault stuff.
Yeah, it's coming from a manufacturer who wants to sell more arc flash reduction technologies in fire pumps applications.
But you look at,
go ahead.
But you look at this the same thing with fire alarm systems, right? And if you look at 760, I think the kind of general concept is the same language is up in 760. You don't want to have arc fault or ground fault protection on circuits that are feeding things that have to do with fire alarm. I think they don't want any possibility of nuisance trip, and I think that's why they're trying to avoid these technologies on these feeders and this protection.
Yeah, and I think one of our first slides that said we're not really worried about personnel safety. I mean, we're worried about personnel safety indirectly because we're putting out a fire to save the structure, to let you get out and, you know, let the sprinklers work and all this other good stuff. But we're not necessarily worried about creating that shock hazard or creating an arc flash event and things of that nature. We just want this puppy to run, and we want it to run until it fails because you need it.
Yes.
Yep. Can't use phase converters as well. So, oh, okay. So this is a little comparison you put together. I like this.
Yeah, and I think this, you know, hopefully it's helpful to the person that's listening here or the user. So what you look at here is, you know, like when we start off, we had the general requirements in NFPA 20, and then we moved to 9.2, which is normal power, and says, okay, how do we wire the fire pump? 9.3 says, okay, we have what are the alternate power sources we can do, and why would you use one? And we have voltage drop. Then we go to motors, generators, junction boxes. If you go to NFPA 70 in Article 695, there's the ones in NFPA 20. There are 5 ways to wire a fire pump. If you go to NFPA 70, some of those 5 ways are kind of sprinkled throughout those requirements. So 695.3 talks about 3 ways to wire a fire pump, and then you talk about, you know, transformers has another way. So there's the same information is there. It's just maybe configured a little bit differently.
Yep. There's a good discussion going on between Al Teresi and Brian Rock about the enclosure. So Al is saying, or an enclosure with an ingress protection, IP rating of IP31. And IP I always think of as like finger safe type of concept. And I think they're talking about the enclosure types and whether or not that's like a type 2 or whatever. And he says, and then, you know, Brian said, look at informational note number 2 on 110.28. That says IP ratings are not a substitute for enclosure type ratings, which I completely agree with. But then Al pointed out that that's NFPA 20. So, Larry, there might be a little correlation issue between NFPA 20 when it comes to the enclosure types that you can use. That's something to think about.
Yeah, I'm sure that, you know, over time, as these standards get revised, you know, sometimes one tends to take the lead and another one maybe is a little behind. And that's where we put these task groups together to try to correlate and figure out some of these issues.
Yep. And, you know, Don points out a good point that if he points out a good point, if you look at 695, and you'll see this in 445 and in other articles where there's extracted material, and 695 is polluted with this, you'll see a paren at the end. Like for example, on-site power production facility tells you about the fire pump, and then at the very end of that, in the square brackets, it has 20:9.2.2 or paren 3. So that text is extracted, and when they do that, it's verbatim, right? So whenever
for the most part, verbatim. I mean, as long as you have the full context of you know, some people say, well, it has to be verbatim, but I mean, I think if you change 1 or 2 words that still fit the context, the exact context, I think you're okay. So there's some debate on it. How you know.
I know we had that discussion, and I think it was NFPA 78 or maybe it was 110. I can't remember. I think it was 110 and 111 when we were having our second draft meetings. There was some extracted materials, and we had this debate because we changed a couple words. We still left it as extracted material, but we had to change those words because it fit better with how it read in our article, but in our document. But in any case, you're going to see a lot of where you have extracted material in 695 pulled right out of NFPA 20. And I don't see any other documents. I mean, it's primarily NFPA 20 where you're pulling all the information from. All right. Thanks, Dawn. Good point. Power sources. Now we're going to get into power sources. So this is determining your normal power source. Now, Larry and I had a discussion about this, and Larry, I know you came out, you know, and I know you do this a lot more than I do, but from my perspective, I would look at this as the first thing I need to determine is, am I going to be powered from a utility? Is the utility reliable? Do I need a second source, or am I going to do on-site diesel engine? And I know you looked at it from a perspective of just your thought process was, I need to get power to a pump, right? And that was the utmost important thing for you.
Yeah, well, I thought I was looking at I was trying to look at the way, tell me the 5 ways I can wire it, and then let me pick one of those. And then from there, I'm going to go say, okay, now once I pick my method, okay, now what do I need to do for, do I need a backup? How am I going to do those things? So you looked at it a different way, which is perfectly fine.
Yeah.
And so there's no right or wrong answer. So, but in either case, everybody ends up getting to the same result,
Yeah.
Same
So,
result.
and so the way we orchestrated this was, you've got to figure out if you're going to take it from the utility, and then you're going to have to obviously determine the reliability of the utility, which was a very early question in the chat box on this. So you've got to figure out, do I have a reliable source? And we're going to talk about that. If you do have a reliable source, I think it's pretty straightforward. You pick one of those 4 methods, and you can supply power from the utility. If it's not reliable, then you still have to pick one of the 4 methods, but you're also going to have to provide an alternate source, or you can skip the alternate source and the primary source and just simply go to a fire pump or a diesel generator fire pump, right?
Correct. You can do that, and that satisfies all requirements for reliability.
Yeah. So, and I know we'll probably get into it too, but so in my mind, it's like, why would you even try to go through the reliability, argue with the AHJ to figure out if it's reliable or not, figure out the sources. If I have to do an alternate source, why wouldn't I just always just pick a diesel powered fire pump generator fire pump?
I think it depends on how your building's laid out. Where is your electric service in relation to your water service that's coming into the building?
Yep.
Do you have are you in a downtown building, and do you have to worry about putting that diesel pump inside the building, and you have to worry about exhaust and ventilation and things of that nature? You need to probably have stored fuel on there. You need typically an 8-hour fuel supply for these devices. So, maybe the voltage, maybe you bring in 13.2 into your building and you have to step it down. And once you bring 13.2 in, now you're in a different animal, and you got to provide transformers for the fire pump and things like that. So, maybe sometimes it's a cost consideration to look at, an engine-driven fire pump.
Yeah. So that's you said something important that just sparked something with me. The proximity of the service to the water supply. That would be very important, wouldn't it? Because
like just when some gentleman said there's a lot more maintenance concerns with a diesel powered pump. Yeah, I mean there's a lot of things that go on, and a lot of things are economic decisions, and you have to look at those and to determine what you have, and if you have to put in maybe so let's say you're in an area that requires the power's not reliable, and maybe you have to consider an alternate source such as a backup generator. Well, by the time you buy the backup generator and all those other things, provide fuel source and provide diesel power or diesel fuel for that generator and transfer switches and things of that nature. And
Yep.
And when it's all said and done, sometimes it might, someone might make the economic consideration that they want to do with a diesel engine pump. In my area where I'm at, I do not see many diesel-driven fire pumps. I see more or less fire pumps installed by themselves with either a backup generator or without.
Interesting. So, okay. All right. So that helps me understand. Now, this next slide is it's a little busy.
Mm-hmm.
And this is out of the annex material. When you see an A in front of those numbers, that's what that means, right? That's the annex material? Or
Correct.
932?
So what if you look at NFPA 70, 695, it's really silent on what is reliable. It talks about it, and it says about an alternate source, but it doesn't tell you what's considered reliable. Now, if you go back to NFPA 20, so let's go back. We had the general requirements 9.1. 9.2 basically says, okay, here's the 5 things you can do to wire a fire pump. And then you say, okay, 9.3 says, but if it's not reliable, okay, what do you do? Now, this is annex material, so this is not really enforceable, right?
Mm-hmm.
So, and a lot of times when I've designed things and I go in downtown Cincinnati, for example, and I'm looking at, downtown Cincinnati has, 2 substations feeding it. It's, it's a 208 volt network. People, maybe power's gone down once every 20 years. People, inspectors, plan review officials look at those things, say, you know what? If you're fed from the 208 volt, I consider that reliable. Now, some of those things are determined by the AHJ, and they have their own method of determining whether something's reliable or not. But in the annex here, it basically talks about, okay, well, here we're going to give you some suggestions on what we say is reliable. And so some of the things they've done, they've give you 4 different situations here. So if the source power plant has experienced any shutdowns longer than 10 hours in the year prior to plant submittal, then they're considered that as not reliable. If you have power outages that have not routinely been experienced in the area of the protected facility, I think that's probably written wrong. Power outages that have been routinely experienced in the area of the protected facility. Number 3, the normal source of power is not supplied by overhead conductors. So, the overhead conductors are more susceptible to, maybe, falling tree limbs or things like that nature. And then the last one is only the disconnect switches and overcurrent protection devices are installed in the normal source of power. So if you happen to have, typically the way a fire pump is you're only allowed to have 1 disconnect between those service conductors and the fire pump. So if you have more than 1 for some strange reason, you have to consider, it's not reliable because someone can turn those off or some overcurrent devices can trip. So at least NFPA 20 does give you some criteria that you can use to help make your judgment about whether you need an alternative source.
Yeah, excellent. All right. There's your on-site generator. Now that's the other aspect of reliability, is to know where you're going to get the fuel source for your generator, right?
That's correct. That's correct. And so you're not going to see this in NFPA 695, but in NFPA 20 talks about you need to have 8 hours of fire pump operation. You need to have 8 hours of fuel supply for that generator.
Yep. Right. Now these are your sources. You got 5 options, right?
Right. So you have 5 options. And so if you look at this in 695, these things are kind of spread out, right? So we go 695.3A1, A2, and A3. So those are electric utility service connections. So that is basically taking a feed directly from the utility and going straight to the fire pump controller. Number 2, A2, is your on-site power production facility. So that's your diesel engine-driven fire pump. And number 3 there, A3, is a dedicated feeder. And that A3 is really where you tap off the service in the separate compartment, put a disconnect, and then head to your fire pump controller. So, but then you kind of switch to 3C and talk about multi-building campus style complexes. And then you skip to 695.5, which is transformers, if you put a transformer in that circuit.
Okay, now Jeff Facteau is on the line. Thanks for joining us, Jeff. He says if the service is 13.2 and all the utility offers, and I guess that's all the utility offers, not campus style application, does the service or the fire pump also have to be 13.2? He goes, we passively mentioned a transformer.
I've dealt with a couple of these, and what in my experience, what happens is that most of these you're not going to put in a 13.2, fire pump, so you're going to need to put some type of step down transformer. So in these situations, you tend to have, and I think it's mentioned in NFPA 20 that if you have a feeder that has more than 1 disconnect, and you can step that down, but then you're going to need an alternate source of power because you have more than 1 disconnect. So that is something that you need to. Where I know some AHJs are sticklers for this, saying that okay, well you have to take a. I've seen people say, well, you have to take a 13.2 feed, and you have to take it to a transformer, a 13.2 to 480 step down transformer with no overcurrent protection, and then hit your fire pump. People said, well, I'll let you do that if you put in an alternate source of power. So I've seen a couple of different arguments. I think that it's, putting in a 13.2 step down transformer, there's a lot of stuff that's going to play there. That's why someone might say, I'm gonna try the diesel engine fire pump. But I've seen it different ways. And this comes back to the 90.4 issue. I think you need to work with the HJ to come up something that serves everybody's purpose.
Yeah, and Al pointed out that the 695.5 addresses that. And I know you can get medium voltage fire pump controllers too. So you can get a medium voltage fire pump and controllers associated with that. I'm not sure, the voltage levels and things of that nature, but 695.5 does hit your generators.
Well, but 695.5,
your transformers.
695.5 basically talks about, putting the transformer in there, and it only talks about having so in this case, you'd have a 13.2 disconnect going to a 13.2 to 480 step down transformer,
right,
which is going to be pretty beefy and pretty costly and stuff like that, and then go into a fire pump. And, as we all know, maintaining and working on 13.2 is not as easy as maintaining and working on 480 or 208. So again, even though that's in there, I've seen people try to work with the HJ to come up with other alternatives to put an alternate source to make sure that they comply, but maybe make maintenance and other things a little bit easier.
Cool. Excellent. And then this one is a little screwed up. Thought I had that fixed. Service connection, on-site power production. So this is your normal power connection to the pump, right? So
yeah, so the original one was 695, and
yep.
It had those things that you had to kind of search for them a little bit more because they were not in, 3 A, B, C, D, and E. So this one here has in NFPA 20 is basically saying, okay, here's my 5 ways of wiring a fire pump, and it's service connection, on-site power production facility, dedicated feeder connection derived directly from the dedicated service, tapping off the service. 4 is the multi-campus style feeder, and 5 is the dedicated transformer connection. So to me, it's a little more coherent, a little more closely tied together.
Yep. And I like that.
And it's a little more closely tied together based upon the way you showed that slide. A little more scrunched together.
I know. I thought I fixed
that. Was
that.
For effect.
That's somebody who uses the automatic design mode in their PowerPoint slide decks instead of, taking the time.
That's right.
So what we're going to walk through next are the different options, right? So this is your dedicated service connection, which is probably your simplest application where you're just coming straight off that service and you're coming into the fire pump controller. The fire pump controller will be service entrance rated and listed with all your bonding and all that good stuff in there. And then you'll go down to the fire pump. So a very simple solution.
And, and also too, some people get confused because, when you have services and you have a fire pump that only needs 3 wires and you tap off that service to go to the fire pump, you have to go, the first means of disconnect, you have to bring that neutral there, whether you use it or not, right, even though it's a 3-wire fire pump. So sometimes people get confused on that, and you got to think of those things.
Yep. And then, and I think this next slide is just and this was nice because it shows that you're coming off of the line side of your service disconnect, not the load side. That's a critical point, right?
Correct. And the takeaway from this is looking at 2 different things here. So one, you see that the fire pump service conductors come in from the service from the utility company. They go into that first cabinet. Once they go into that first cabinet, then they come back out of that cabinet. They tap off that on the load side of the metering cabinet, right? So most of the time, all the time, the utility still wants the fire pump meter, even though the fire pump is never used for, we don't want it to be used, of course, right? Because we know that that's a hazardous condition if something's really happening in the building if we're using that. But so you tap off there, and then you go to the fire pump controller. A lot of things that I see today, so if those might be in existing buildings, but in new buildings, most every time that I see it nowadays, everybody's trying to come put the metering at the transformer, come straight from the transformer, into the building, and going directly up in the fire pump controller room. So, you can do it both ways. There's nothing wrong with either way, but that is option number 1 on how to feed the fire pump.
Cool. And then you got option number 2, which is your on-site power production facility. And that's all self-contained, right? So that's all listed together. The fire pump controller is on there. The generator, the diesel generator is on there. The engine is on there. The diesel engine that's turning.
And you can see on there the water connection, the water pipe connections on the bottom left of that pump. And so that is self-contained, and it's considered reliable. You don't need to worry about the choice of whether you need another source of power, but you do need concerned about ventilation, fuel supply, combustion air. Like I think Don said before, if it's outside, you got extreme environments and, things like that. It might not be the best choice. So, but that is another way you can wire a fire pump. That was number 2 on that list.
Yep. And then there's number 3, which is a dedicated. Now, when you say feeder, it's not a service. So this feeder is coming from another piece of equipment, right?
That's correct. So basically that is, number 1 is kind of coming from the service straight into the fire pump, and or going into that switchboard and going straight to the fire pump. So there's no overcurrent protection. So those are considered service conductors. If you were to do this option, number 3, you would tap off the service. You could either tap off the switchboard and set a disconnect next to the service entrance, or the service switchboard, or somewhere next to the service, or you could come from the transformer and set a disconnect. Once you set that disconnect overcurrent device, then that becomes a feeder, and then you run that to your fire pump controller.
Yep. Indeed, Don Ganier pointed out, whenever I say diesel, I immediately follow that up with generator. There's no generator on that. It's just a diesel engine turning a pump.
And Don, I've been trying to correct him all day, but he still doesn't.
I know, I can't break bad habits. That's a good habit, right? Number 4, campus style. So this one's always, I know whenever I do programs on, we get questions. This always comes up as a confusing point for a lot of people, because I think when you have a large facility, they want to leverage this campus style option, but there are special considerations with regard to all of these overcurrent devices that you have upstream of that fire pump, and the details can be challenging to get by to make an installation meet all the aspects of this requirement.
That's correct. So yeah, this is a little more. So basically, when you do have campus styles, these are basically having feeds coming from buildings. So they're not really service conductors. They come from some medium voltage setup, where there's some type of, and then they have an overcurrent protection device, and then they become feeders. So number 4 strictly talks about feeder connections, and if providing backups sources of power. So if you have a feeder from a campus style, you really want to have a backup generator or backup source of power. That could be 2 feeders. So there's other ways to do it on a campus style. So a little more complex.
Now you could have a direct service feed going down to that fire pump on the left leg, and then come off of like the Article 700 system as a backup for that fire pump as an alternate source, right?
That's correct.
Right.
That's correct. You could do that.
And Felix had a question. He says, are there special requirements for the diesel generator if it is the only power source for a fire pump? So you got, Larry, correct me where you think I'm wrong, but I think you have to look at the reliability, right? So if your primary source isn't reliable, your backup power could come from a diesel generator that's supplying power to this pump, like you would have as part of your Article 700 system. But is there a requirement in 695 that your alternate source has to be like from an Article 700 system, or any special requirements on that diesel, on that, like if you're using a diesel generator or whatever that second source is, are there any special requirements for the second source?
Well, let's go back to his question. So his question is there any special requirements for the diesel generator set? It is the only power source, right?
Oh yeah, he did say the only power source. Yeah.
And so the way I interpret 695 is that the first thing it says is electric utility service connection. Okay. So I said, okay, that's the only way that you can wire that for number 1. Number 2 is the on-site power production facility. So that is basically an engine-driven fire pump. It's not a diesel generator. And number 3 is a feeder. I do not think that you could, in some cases, I think if you had a generator only, you would not be permitted to do that. In my opinion, you would have to go to the engine-driven fire pump.
Yeah. Yeah. Now there's in what section is this? 695.3 D says on-site standby generator as an alternate source. There are three requirements. You can use a standby generator as an alternate source, but you have to address the capacity, the connection, and adjacent disconnects. So there are special requirements. So you can use it as an alternate, but I agree with you. You're going to be using an integrated unit that's listed for your if it's your primary source.
Correct.
Yeah. All right. Can't switch in time. Oh, so Eli says you can't switch in time if it's a gen set only. I don't know. I'm not sure what that means, but. Number 5 is your dedicated transformer connection directly from the service. We already talked a little bit about this one, right?
Right. So, if you do have a different voltage coming in than your fire pump, you would go ahead and you'll have your main service disconnect right there.
Mm-hmm.
Then you'll have your transformer, but you do not put any secondary overcurrent protection from that transformer over to your fire pump controller.
Right. Excellent.
We did this. We had this right now. We're retrofitting one in downtown Cincinnati. Originally, we had a 208 volt, and we'll get into this a little bit, but we had a 208 volt service, and we had a 480 volt fire pump. So we stepped it up. And when they put the new fire pump in, and we'll go over the voltage drop issue in a little bit, but we got rid of the transformer, basically because of the voltage drop thing, and then we'll go over that.
Interesting. Okay. All right. Now, all of that we just talked about, it sounds a little complicated, but again, you have these options. The wrench that we're going to throw into the whole discussion is when you're dealing with a high-rise building, because there are special requirements that you have to follow as part of NFPA 20. I think NFPA 20 was the location. There wasn't anything in 695, right? If I'm not mistaken.
Correct. There's nothing in there that talks about, alternate sources of power for high-rise. There are things in there that talk about high-rises in Article 700 if it's an emergency system and it's a high-rise, you need to provide, an alternate source of power. But for fire pumps, where it mentions high-rise is specifically in NFPA 20.
Right. So this is telling us that you need an electric motor-driven fire pump as with a normal source of power as a continually available source.
Correct. So the first thing is 9.2.1 says you got to have a normal source and it's got to be, continuously available. Yeah. And then it goes on from there and it says, okay, and I kind of skipped a couple things in here, but in 9.3 it says, unless there's an installed power range as described in 9.3.3, at least one alternate source of power shall be provided for high-rise buildings. Now, 9.3.3 talks about the engine-driven fire pump. So if you have that, you don't need an alternate source of power for a high-rise. But if you have your utility service coming in and you need an alternate source of power, or you always need an alternate source of power for a high-rise.
Okay, so if I'm in a high-rise, I'm always going to have an alternate source of power unless I use this.
Correct.
If I use this, then this could be my only source of power.
Correct.
All right. Mohammed says, so based on that picture in the previous slide, you're not allowed to have an overcurrent protective device on the secondary of the transformer if there is primary protection. So he's looking at this slide here. I think what your point was, Larry, it's not, you don't need it if you have primary protection. We're saying you need the primary protection. Okay, that's definite requirement. That's a requirement for transformer protection, period. But you're not allowed to have a secondary protection, regardless of what it says in Chapter 4. Correct. Hopefully, Mohammed, you got that one.
And you're going to end up going to that. You're going to end up, when you go to that fire pump controller, that fire pump controller is in all reality going to have some type of protection, some type of overcurrent protection in that fire pump controller.
Excellent. All right. And then 932 says other sources, except for an arrangement described in 933 as at least one alternate source. And we already talked about that. Okay, now the next slide is 695.3, talks about the sources. So I think this is a little bit of a regurgitation, right? Or is this?
Yeah. So this kind of tries to bring it all together. So, so if you have 695.3, it talks about individual sources. So that can be, utility service, your engine-driven fire pump, or a dedicated feeder. You got to talk about multiple sources. So you could have, multiple sources feeding a fire pump with some type of transfer switch. So you could have a combination of individual sources. You could have an individual source plus an on-site standby generator. And then when you get to multi-building campus style complex, you could have multiple feeders. You could have a feeder and owner source. So you could have a whole bunch of different things in there.
Now you threw selective coordination in there, and I think that's a discussion that's important, because the moment you have those different layers, they have the selective coordination requirement because you don't want to take out multiple. It's all about reliability. So and that's the situation where you're going to have multiple overcurrent devices, is you have to make sure you've got properly coordinated. All the other,
correct. Especially when you have feeders, you're going to have probably more than a couple of disconnects.
Yeah, but the other, when you have a direct feed, I mean, you're coming off the service. There's nothing to coordinate.
Correct.
All right. All right. So disconnect. Oh, one disconnecting means so you're going to need a disconnect.
Right. So this is the whole key. You just want one disconnect in the system between the service and the fire pump controller. So, so this is 9.2.3. This is similar in the Article 695, but I kind of highlighted the yellow part. No more than one disconnecting means an associated overcurrent protective device shall be installed in the power supply to the fire pump controller.
Right. And then I think I like this diagram. This sort of gives you a good overview, right?
And, that overview right there that you're seeing, that is taken from NFPA 20. So, and I guess I put this in there just so people kind of looked at each one and said, look at the first one. That's a direct service connection. There is no overcurrent, or there's no disconnect between there and the fire pump controller. The fire pump controller would be considered the disconnect. So that's right. That looks like that satisfies that in A. In B, the only disconnect you have there, you have a transformer, but there's only one disconnect between there and the fire pump controller. And in C, that is a direct feeder. So again, you have one disconnect up to the fire pump controller.
Yep. And in each of these, you show that fire pump auxiliary loads coming off of the same feed. To the earlier comment in the chat box, that doesn't have to come off of that. It could come from anywhere, right?
Correct.
Yeah. Then there's no requirements of the reliability nature for that auxiliary equipment. If you wanted to pull it off of wherever, you can. But normally that's what you do. You do pull it off of that same feed because you got it there.
Well, I'm saying is for those auxiliary loads like the pressure pump or jockey pump, those are such smaller loads that, like Mather said before, it's tough. I've never really seen one tapped off. I've always seen them have a separate branch circuit for those loads.
Yeah, and Mather is saying, and he's out of New York City, so he sees a lot of fire pumps, I'm sure, on a daily basis. The requirement for alternate power sources are located in the International Building Code, mainly Chapter 27. Even the NEC doesn't speak about the requirement. It's the building code where the authority having jurisdiction, and he is the AHJ, Chief Electrical Inspector down there, has the fire protection system. So the AHJ is going to be referencing Chapter 27 in the IBC for a lot of this stuff. For that
right,
source.
And then that's the same thing. And I know New York is a lot more massive than Cincinnati, Ohio. And you look at Cincinnati, we have various networks downtown, whether it's a 208 volt spot network or the 40 volt. And most of the time when I come in these situations, I go to the local HJ and say, okay, here's what I'm trying to do. What do you think? And so they typically have a way that they handle these things for reliability.
Excellent. All right. So we're continuing our on in chapter 9.23. So if it's service equipment, it has to be obviously identified as suitable for use as service equipment, or it could be suitable only for use as service equipment, right? I guess it depends on how it's designed.
Correct. So, but these are the requirements for the, the disconnecting means, and that disconnecting means could be the fire pump controller. So whether that disconnecting means is tapped off the service or it's a fire pump controller, it has to be suitable for use as service equipment.
Right.
And then, you have to be lockable in both the closed position and the open position. Shall be located remote from other building disconnecting means. It shall be located remote from other fire pump source disconnecting means. And, number 3 is a little bit tricky because, it says it needs to be located remote from other building disconnecting means. When you have an existing building and you're tapping off the service, it is kind of difficult to locate it remote from other building disconnecting means unless you do something as far as trying to, protect it. And, maybe you have to trench to get the conductors outside the building, to put it remote from the other building disconnecting means. So 3 is kind of tricky in trying to work around existing building conditions.
Yeah, and I guess
5. Go ahead.
But just the whole aspect of remote. I mean, that's a pretty vague statement just in general. Remote to me might be 10 miles away, but remote to you might be 10 feet away.
Correct. And the last thing is it shall be marked fire pump disconnecting means in letters no less than 1 inch in height. So those are kind of just the requirements for the disconnecting means.
Yep. Now, Mathra Abbasi, Felix says, is overload protection forbidden? Like your thermomagnetic, I guess, on the motor. I mean, we have protection of the motor. There's overcurrent protection, but we're not worried about locked rotor and whatnot, right?
Right. I mean, you're not going to want to put, you cannot put overload protection in these circuits because, you don't want it to trip.
Right.
And so if you end up with the locked rotor condition, that's why you size a lot of these circuits above the locked rotor current to make sure you're adequate, that you don't have nuisance tripping.
Yep. And then Mather is commenting about selectively coordinating one level of overcurrent protective device, and he's right that you would only have to do that in what do you call like your feeders when you have multiple overcurrent devices. All right, 9233.
Well, one of the things is I think it's a question, where do you apply coordination on one level? I would assume that means that if you have a fire pump controller and a fire pump disconnect tapped off the service, you're going to have, I do not think the code is silent there on the coordination. So once you tap off the service, you're going to put a service disconnect, you're going to put a fuse or a breaker, then you're going to go to the fire pump listed controller, and that is going to have its own overcurrent protection, but it's really kind of silent on how that is on how that coordinates.
Yeah, it says selective coordination. Overcurrent protected devices shall be selectively coordinated with all supply side overcurrent protected devices, and that's only in the multi-building campus style complex. If you're coming directly off of the service, you've got one overcurrent device. Now, to your point, you might have some other things inside of the controller, but the only place where there's a selective coordination requirement is when you're dealing with a multi-building campus style complex and you're employing the feeders and whatnot that you would have in those types of applications.
Correct.
Right. All right. Did we cover this one already? Locking disconnect means in the closed position. We already talked about that. Supervised in the closed position.
Right. So you got to supervise it. You want to make sure that when, if you open this up, it sends a signal in some fashion to the fire alarm and says, hey, you open it up, you turn that power off. So you can either supervise that by a connection to the central station, or you can actually lock the disconnect means in the closed possession. You can do that as well. I've seen that. I've seen it in both cases. I actually think people do both 1 and 3.
Excellent. All right, short circuit protection. So this is getting in now. Now, Richard Curran asked a question: can I fuse it if I can carry locked rotor indefinitely? And the answer to that would be yes. You can use a fuse or a circuit breaker. You just have to be able to carry that locked rotor amps. Correct.
Yeah. So typically, a rule of thumb is these devices can carry 10 times and indefinitely. Yep. Right. So if you fuse it exactly at what the rating of the motor is, it could trip. So you want to make sure that you trip it. You size that long time above the lock rotor, which is typically 6 times whatever the motor is.
Yep. And these are all your general tips. So it's short circuit protection only. We already talked about that, answering the question about the overload. We talked about ground fault protection of equipment is not permitted. No overload. There's no overload protection. We talked about did we talk about the taps? Yeah, the taps, again, 230.6. That's in your services.
Mm-hmm.
And then conductors directly connected to the generator without output. Again, 2.25, 2.25 times the full load current of the fire pump. And that's all 695.6A. So this is just some general overview from an overcurrent protection perspective. Anything else on that one?
No, I think we're good on that one.
Bam! Now this is picking your overcurrent device. So we already talked a little bit about this, right? So this is just your instantaneous, just your no overload protection, basically.
Right. So, you look at this, you have two ways to size the overcurrent protection. So, it splits it up between A and B. A is for individual sources and B is on-site standby generator. So you have to look at this in two different ways. So if you have overcurrent for a disconnect or breaker outside a fire pump controller, so those are where you tap off a service and you provide a disconnect ahead of the fire pump controller, and that's an individual source. Or if you do a fire pump controller, that's a listed assembly. So you treat these two different ways, and then actually you also have on-site standby generator. That's really a third way, and so we kind of go into that in more detail in the next couple slides.
Yeah, that's weird how they. It's almost as if it's a little bit of a problem with the code book because they grade out both areas. You have 1, 2. 2 has A, B, C, D, and all of a sudden there's a B on-site standby generator. I think that should be 3.
No, I think they're just saying that if you have individual source, here's what you got to do.
Yeah.
Because you want that locked rotor. So the one really is saying, hey, you got to handle the locked rotor in A, and B is saying you don't really need to worry about the locked rotor.
Gotcha. All right. Good one.
And so this is kind of the main requirement for an individual source. So overcurrent protected devices shall be rated to carry indefinitely the sum of the locked rotor current of the largest fire pump motor and the full load current of all the other pump motors and accessory equipment.
Yep. And then
so that's where the 6 times comes in.
Yeah, and that's what Bruce is saying. It's important to mention that the overcurrent device is 600%, but the wire only has to be 125%. Transformer must put out 600% full load amps at allowed rated voltage drop. So, and we're going to get into the voltage drop concerns and whatnot. So when you have that transfer, those are some important details. Is when you're picking the transformer, when you're sizing your overcurrent protected device.
Correct.
Did we hit this one? Exception: the requirement to carry locked rotor currents indefinitely shall not apply to feeder overcurrent protected devices installed in accordance with 695.3c. And what is 695.3c? And that's your multi-building? Is that what that is? Yep, that's your multi-building campus-style complex. All right. Oh, sorry about that. Hit my mic. Okay, so assemblies listed for fire pump services. So this is getting into provided by an assembly, shall be provided by an assembly listed for fire pump service and complying with your A through D. And this is right out of this is out of the NEC because there's a reference to NFPA 20 there. And this is your 600%. Your overcurrent protected device shall not open with restart transients of 24 times the full load, and the overcurrent device shall not open within 10 minutes at 300%. So this is sort of giving you how to compare that trip curve with these data points, right?
Yeah, 2 things I want to go here, and then I want to look back at Bruce's question. But like, if you look at that assembly listed for fire pump service, so they treat this differently than your disconnect. These are listed fire pump controllers that have been tested. They give you, these really do not have to be they're a little bit different. The one that's a disconnect that's tapped off the service, it has to be able to carry locked rotor indefinitely. This talks about 600% of full load current for 2 minutes and things of that nature. So these things here are a little bit differently, and they give you a little more leeway because these are listed components that have been tested at the factory.
That's true. Yeah, because and then you would pick these controllers based upon the size of motor and whatnot that you have, and all of these considerations are probably handled as part of the listing.
Correct. And so going back to Bruce's question, I don't know if he meant to say this or not, but on a transformer does not have to be sized for full load of 600% of the locked rotor. It just has to be sized. You have to size it 125% of the fire pump, but you have to worry about the voltage drop, and that's where the 600% comes in.
Okay.
So that's what he might have meant. That I just want to make sure I clarify that.
All right. Good point. Standby generator, on-site standby generators, overcurrent protected devices between. Okay, so this is the C op. This is that on-site. That's the B option. We hit individual sources. Now we're hitting on-site standby generators.
Correct. And so this is the key. So again, A, you need to worry about locked rotor for your individual sources. B, if it's a standby generator, we don't need to worry about that. So we basically can put our overcurrent device in for the generator and just size it, correlating it 125%, the wire and things like that, and go ahead and do it as you normally would do a motor.
Perfect. And this is your 695.4B2. So we're in B now. Oh yeah, B2A1.
And this is kind of just basically kind of summing everything up.
Yep.
So if you have an overcurrent protection, it must be set to carry indefinitely the sum of the locked rotor currents plus all other fire and jockey pump motors and plus all their loads. You can still go back to 240.6 and you can go to the next standard size. And locked rotor requirements apply only the overcurrent device, not the circuit conductor. So the circuit conductors are sized at 125% of the fire pump.
Yep.
And we mentioned there locked rotor currents found in table 9.5.1.1 of NFPA 20, and that's not necessarily true. You could find those requirements, those locked rotor currents, in both NFPA 20 and in NFPA Article 4 or NFPA 70 Article 430.
Right. For motors. Yep. So it's the same data from a motor perspective, but cool. Then there's your supply conductors. So now we're getting into power wiring. So these are your supply conductors, and talking about the service conductors supplying the on-site power production facilities. And this is going inside versus outside of the building. So you're still looking back at 230 for service conductors because it is a service conductor, and you're going to have to follow those same rules.
Correct. So again, the service conductors are not really protected, like the NEC protects conductors a lot more closely to their ampacity than maybe a utility company does. Maybe the utility company wants to have a little bit of fat in there for nuisance tripping and for economic reasons. And so we need to make sure that when we do these things and we look at service conductors, that we're tapping off a transformer going directly to the fire pump transfer switch. We need to make sure that we do something special with them. And if we do that, we need to make sure that we route them outside the building.
Yep. Oops.
Now that is both on-site power production facilities and service conductors.
Now, when we're dealing feeders, that means we have an overcurrent device up ahead of us, and we're following 695.4B.
Yeah, so fire pumps, we have a feeder. We say, okay, it allows us to do something a little bit additional. It says, okay, yes, you're protecting that at where you tap off, but now that allows you to run it through the building if you want.
Yep.
You could, of course, bury it or bury it underneath and come back up and through concrete into the fire pump control room. But if you decide that you want to tap off and set your overcurrent device, now you have some additional rules you have to follow by the time you're going from that disconnect to your fire pump control room. So these rules, as you're putting it up on the screen, is one, you got to have it independent routing. You can't really put it with other types of wiring. You got to keep it independent. The conductor shall supply only loads that are directly associated with the fire pump system. So you can't mix and match other types of HVAC equipment or whatever. It has to be, the feeder has to be only for the fire pump system, and you shall protect it from physical damage. So we don't want anything to happen to that feeder because it needs to be, if it has to be called on in the case of a sprinkler going off, we need to make sure that it is able to do so and nothing's going to damage it. But I think the most important ones are on the next slide. If you're going to ride inside a building, you're going to have a cable or raceway encased in 2 inches of concrete, or you're going to have to put it in a raceway that's a listed fire resistance cable system, or you're going to have to have a listed electrical circuit protective system. I see, and you know, when I first started doing this over 30 years ago, I saw, you really only had, in my mind, if I can remember correctly, we only had concrete, or we had people would wrap conduit with some type of 2-inch to get a 2-hour rating. And today, more and more people are starting to use maybe listed fire resistive cable systems, something where you maybe put a special, like I think Draca makes it. It's an EMT with a 2-hour rated RHW cable inside. So I also see people, people still use MI cable, that's 2-hour rated, but I see more and more people using other type of EMT with specialty cables inside.
So this is a nice layout. Why don't you speak this? Do you mean walk through this?
Yeah, and it might be better if you put I know this is hard to see. I hope everybody can see it, but maybe it's, and this is a job we're doing here, and it came up the other day, and I thought it'd be interesting to put this up there because this shows some of the challenges you have. So for instance, if you have an electric room there on the right and the fire pump room on the left, and then there's a small room in between. So, you have to make a decision there between going, you do not have to protect for 2-hour rating if you're in the electrical room or the fire pump room. But if you leave those rooms, you have to do something and protect it for 2 hours. So you have to make a decision there. So when you tap off that switchboard, set your service disconnect, and then I go into my fire pump controller. Okay, do I tap off and do I put in my MI cable? Do I run it? Do I run my EMT with my Draca all the way from the switchboard? So you have to make some decisions there. Do I splice the conductors in between and change over to my wiring method? So, you have to make some decisions.
Yep. And if you had your druthers, you would probably, you put the fire pump closer to the electrical room, there's less decisions you have to make. But like you said earlier, you may or may not be able to make these types of arrangements. And it might be just as easy just to put it under the pad or put it into the cement, and then you don't have to worry about it.
Correct. And a lot of times, the plumbing engineer is going to dictate where the water goes. And so sometimes you're left with a few options.
So a plumber's going to tell you what to do?
That's pretty much it. Yeah. Now there's one question that just came up. It says, does that rating apply to emergency feeder from a genset? And yes, that would also require you to run that in a 2-hour rated cable or listed assembly.
All right, so now we're getting into the transfer switch discussions, because if I have my transfer switch, that means I have 2 different sources basically feeding this fire pump, and that means that I've already made the decision that one is not as reliable as I need it to be. So now I have an alternative source, and that's when I get into my transfer switch. Right.
So these transfer switches, they have to be listed.
Yep.
They have to be dedicated for that fire pump. You can't put other loads on there. When it's suitable, and this is the whole theme throughout the NEC. This is not just strictly for fire pump transfer switches, but it goes for transfer switches. It goes for overcurrent devices. It goes for receptacles. It goes for everything. Each device that you install in an electrical system has to be suitable for the available short circuit current. I think a lot of people, a receptacle has a short circuit current rating at 2,000 amps. Not many people know that, but each device has a rating, and so we have to do that for transfer switches as well, and fire pump transfer switches. The last one, ampere rating, here is a little bit unique in that the power transfer switch shall have an ampere rating not less than 115% of the motor full load current. So it doesn't have to be at 125%. It strictly has to be at 115%. But you got to watch it, because sometimes, depending on what type of transfer switch you pick, you might have to oversize the transfer switch to meet certain requirements in the NEC.
So I'm just looking at the dialogue there. So Bruce said, if you use MI cable, make sure to put engraved signs on it every 10 foot saying this is not a water pipe. Felix says no. I'm not sure what his response was to, but he says not even the Jockey pump under the same ATS.
Well, you could put the Jockey pump under the same ATS, because I think that, that is it is feeding fire pump equipment. Okay, so you could do that, but again, most people do not worry about. A lot of people, sometimes I don't even see to put the Jockey pump on a generator. You can do that, but it's typically come off a branch circuit.
So we said the ampere rating has to be not less than 115% of the motor full load amps. And Mather is saying, what about the locked rotor current?
You do not have to size that for locked rotor current.
You have to be able to switch the locked rotor current. Right?
I think that this does not have to be rated for locked rotor current.
But 10834 says, and shall also be suitable for switching the motor locked rotor current. So you don't size it per the locked rotor current, but you do have to be sure that the withstand close-on rating, I guess you would say, and the short circuit current rating, because whenever I think of switching, I think of the withstand close-on ratings, but I'm not sure if that's accurate from a transfer switch. You have to be able to switch the locked rotor amps. At least that's what that implies.
I would assume so. Yeah. So you might have 115% rated for motor full load current, but these things typically have really high. They'll have a significantly higher fault current rating, so
right.
They should be able to handle for a specified period of time that locked rotor current.
So these are a couple good images.
And this is kind of a couple ways you can handle transfer switches if you needed, an alternate source of power. So the one on the left, that has a fire pump controller and a power transfer switch built in the same enclosure. Or you could do it on the one on the right. You could have a fire pump transfer switch that's separate in a separate enclosure, and also a listed fire pump controller. So there's a couple ways you can do that.
Yeah, and all of that can be listed as service entrance rated too. So, that's another little aspect you got to keep in mind as well. And then you got the withstand close-on.
There's a question there for fire pump.
Whoop.
There's a question in there for a fire pump, a source of fault current. I think fire pump is a source of fault current. Again, you got to look at some of the ways that I was taught that if the motor's 50 horsepower or greater, that you sometimes you multiply by 4 to get the amount of fault current that would contribute back to the fault. So if it's less than that, I was taught to ignore that.
Now there's drives you can put on a fire pump too, right?
You could put drives on a fire pump.
And if you have a drive, then you wouldn't have to worry about the motor contribution from it.
Correct.
Yep, because you got that. Now the withstand close-on rating, these are, we use the terminology withstand close-on ratings with transfer switches, but it's very similar to a short circuit current rating for that equipment. We don't use the term short circuit current rating. We use withstand close-on ratings, but they're used in synonymous with each other with regard to the code when they say that you have to have an SCCR rating equal to or above the available fault current, like in Article 700, 701, 708, etc. But we label it with a withstand close-on rating, and these transfer switches ship with very somewhat specifics to tell you what they will achieve that withstand close-on rating based upon the overcurrent protected devices upstream.
Right, and so the reason we put this slide in here was more or less like, typically most people are going to go out and get a listed fire pump controller, or they're going to get a listed fire pump transfer switch. Maybe it's a combination, or you're going to get two separate enclosures. If you went out and got a listed fire pump transfer switch from maybe a Cummins or someone else, another vendor, so what happens is you got to size that transfer switch at 115%. And so, for instance, if you look at some of these rows in here, for instance, if you would pick out the third row there you picked out a 250 amp transfer switch, you can wire that with 250, but you can have to, or that's 260. I think my eyes are deceiving me, but you could wire that at 260, but you protect that with a multi-K circuit breaker at 400 amps. So now, if you for some reason had to have an overcurrent device at 6 times the motor, you would then have to bump that transfer switch up to the next row. So even though you had a 200 amp motor, that you could sit there and say, okay, well, I'm going to pick that transfer switch, and it says that transfer switch is only protected up to 400 amps. I would have to go to the next one down and buy maybe a 400 or 600 amp switch with a 1200 amp maximum rating to be able to satisfy the NEC.
Yeah, I agree with that. Now, Mather says, I believe there's no specific listing for ATS for fire pump application. It's just based on the NEMA standards. So that brings up a good point that, if I integrate the transfer switch with the controller, then that's going to be listed as a unit, right? There'll be special labeling
Correct.
and all that. But if my transfer switch is separate, if it's an Article 700 system, I have to list it to a specific standard. But if I'm using it for my fire pump, I can't find anything in 695 that says it has to be listed like you would have for an Article 700 system.
Yeah, and I do not see that too.
Yeah, that's an interesting point. So, Matt, that's a very good observation. I got to look into that a little bit more. I wouldn't.
Now, most of the time when you get fire pump controllers or fire pump transfer switches, those are typically they're rated by horsepower. So for the pump, so they're rated for 75 horsepower or 50 horsepower, things of that nature.
Yeah. A good point. I'm going to write that question down. All right. So now you're going to run through an example, right?
Well, this is just to look at this nameplate. This is a nameplate of a fire pump we just did just recently. So, you look at here, this is, let's just concentrate on a 230 volt motor. This has an amperage rating of 169. So if you were to wire that fire pump, you would take that 169 and you would mark it up 125%. You would pick your wire. So if you look at that there, you would, if you want to look fault current, just to get you in the ballpark, you would take 6 times the 169 to kind of consider your fault current. But what you should do is look at the design code there, B, and try to look at that and then go to a table to make sure you size your overcurrent protection accordingly. So this is a table that is listed in table 9.5.1.1. This is out of NFPA 20. So you would go down to the 75 horsepower motor, and this tells you it's the short circuit current, my lock rotor current is 1085. Now that is with a code G. So go back. I said B, but go back to that slide. So I said designation B, but that said code G.
So, code G. There it is. Yeah.
Code G. So I said B, so inadvertently. So now go to the next one. Now this one's a little differently. This says design. This doesn't say code. This says design B, C, or D. So this is taken out of table 430. And if you go to the 230 volt column for 75 horsepower, it still says 1085. So you can see they match. So you can use either method. So you know that you have to put in something above that lock rotor. It's 1085.
Good point. Good point. Okay. Now we're going to talk a little bit about some application. We're coming into the home stretch. Some application considerations, and one of those is voltage drop. And Larry, you've got some scribble we're going to look at.
Yeah, and this might be a little bit foreign to some people, but I was taught this in college, and I think it's something like in college you really don't remember what you learned, but as you get older, some of it gets more important. You're like, okay, now I know what they meant. And when you look at the voltage drop, you're really not allowed to have any more than 15% voltage drop between the fire pump controlling terminals and the service. And so under motor starting conditions. So you really need to look at that. And to be honest with you, in my opinion, where this really comes into play is when you put a transformer in the system between the service where it comes in and the fire pump. Extremely important. So the voltage at the load terminals for running of the fire pump shall not drop more than 5% below the voltage rating of the motor connected to those terminals when the motor is operating 150%. So you got starting and running. So if you want to go to the next slide. So here is kind of an example of a 15% drop for when you start up. So for instance, if you have a 480 volt system, you're allowed to have 72 volt drop. So down to 408 before to allow that motor to start up. So that's 15%. If you go to the next one there, and this is kind of an example. So let's just take a standard transformer. A standard transformer has a 5.7% drop. Now, people always say, okay, I don't understand percent. What does that mean? And, I've always struggled with that when I was younger. And I think that as I think when you look at that 5.7%, it's really clear if you think about the whole system using percent. So if we were to consider 480 volt as the 100% rated voltage of the system, and we were to have 100% rated current, whatever we determine that full load current is. So if we have a 75 kVA transformer, 100% of the current flow on the primary is basically 90 amps. So if we had 100% voltage, 100% current, we would have a 5.7% drop. So I like to look at those things in that terms. So if you go to the next slide, I kind of drew this up. So if you look at everything in kind of, again, percent. So if your voltage is 1, which means it's 100%, and your load current is 1, by Ohm's law, your voltage drop is 1 times 0.057. You have a 5.7% drop. If you can go to the next slide, if I take and I say I got motor startup current, my motor startup current is 6 times full load or 6 times 100%. So if I convert everything to percentages here, if my voltage is 1 and my current is 6 times full load, if I'm trying to calculate my voltage drop, 6 times 5.7% or 6 times 0.057 gives me a voltage drop of 34.2%. So this is well above the 15% startup. So if you have a transformer that's situated somewhere in this, in the feeder between the service and the fire pump controller, you know that you have to significantly oversize that transformer, probably at least 2 times or more to really make this thing work. Now you could sit there and say, well, maybe I have a reduced reduced voltage starter or some things like that to take into consideration. But if you have across the line start, you have to look at this thing a little bit differently.
Interesting. And that's all called per unit, right? I mean, you're a geek like me. I love per unit and I love playing in it, but a lot of people don't get it.
Yeah, and only until probably about 2 years ago did I get it. So I'm a late bloomer.
That's about when you met me, right? Okay, so required alarms. So alarms, and you mentioned this earlier about 72, right? NFPA 72. And
well, this is actually this is actually in NFPA 20.
Yeah, but there's alarming requirements. Is there a 72 angle here at all with regard to pulling off the alarms from the fire pump system, or no? Am I just smoking weed there?
Well, I mean, I think that NFPA 20 tells you, the alarms that you have to provide for the for the fire alarm system to be able to notify someone. So you're going to basically tie these into the fire alarm system.
Okay. All right.
And so if you look at there's 2 tables there. One of the tables at the top is if you have a single source controller, and the one at the bottom is saying, okay, if I have dual sources. Excuse me. So if you look at that there, I need to have at least alarm type for power available and for phase sequence reversal. So those are the 2 main visible alarms, and there's some optional ones in there. And if you have dual sources, you need to have, for power available, phase sequence transfer switch in normal or alternate position or alternate source is circuit breakers open.
Cool. And then what we did on the next slide was I grabbed one of our, because we make fire pump controllers. Obviously, I don't know what we don't make, but this is one of our diagrams for our fire pump controller. We've got, if you look at the diagram on the left-hand side, you've got your motor. And what I like about this is it sort of gives you it shows you your current transformers and your disconnect switch and all that good stuff. But over on this side on the board where you land and you have all of your wiring, you'll see that you have, excuse me, you have your phase failure alarms, which is required. You have your phase reversal, which is also another part of the requirement. And then you have your pump run, tells you whether it's on or off, right? So
correct.
You sort of have, and then, you have your, like over here on this side, you'll see where it says to the current transformers. So you'll see where you land your CTs and whatnot to get all of the information that, that's how I'm determining whether or not that motor's running. I'm looking at for current and things of that nature. So, and you have any of your inputs and whatnot on this motherboard that are field wired from the pump itself, from the pump to the controller. And then, so these are two examples. So the one example is correct. This would be, I think, in my opinion, this looks like it's a half decent installation, right? So there's nothing wrong with this one in that you're coming off of the service, you're going through that bus cabinet, so there's no overcurrent devices there. You're hitting the CT cabinet, and then you go right down to the fire pump.
Correct. So this one here, some people send me these drawings to look at, and so this one here is tapped off the CT, even though you have you have your utility transformer outside, and you go through a couple of different cabinets. You still keep tapping off. There's no overcurrent protection there, and you run that straight from that meter enclosure all the way over to your fire pump controller.
Yep.
So those are service conductors. That needs to be a service entrance rated controller. Those wires need to be sized for 125% of the full amp capacity of the fire pump and any associated motors that are maybe tapped off of that.
And all of your bonding and protection, that's all going to be a 230 standard 230 wiring.
Correct. And again, even though it's a 3-pump or it's a 3-wire motor, you still got to take the neutral there to that controller. And so these are service conductors, so they're unprotected. So you have to route these outside the building to get it to that fire pump controller.
Yep, that's your house CT cab. I just want to give them a nice little close-up so that if anybody wants to pause this, they can look at it. Now, the next one is a little bit not so simple. I think this one, you have some issues, don't you? Where's your fire pump? So I'm going to zoom in a little bit.
This one here, there's a whole host of problems, and this is why we put this on there. So it is quite interesting. I know I talked to the local plan review official that had this one. They've gone through several iterations to try to fix this. So, for instance, here you have your. If you looked at the little red box on the left, this person was submitting these plans to put a breaker in there that is basically in the switchboard section that is not. So this is not in a separate switchboard section. This is with all the other overcurrent devices, which you're not allowed to do. You have to have it if you're going to tap off that switchboard, you have to have that and not in the section where all the other overcurrent devices are. So that was one issue. And then if you
he's going through another panel.
He goes from there to another panel. And then from another panel there, he goes to a breaker, and then to feed the transfer switch. And I think if you pan down, Tom, a little bit, that is a 60 horsepower pump, 480 volt. So if you go back, he only has, I think, in that existing, panel DP2, only a 200 amp main circuit breaker panel. So we don't have a 6 times the locked rotor. So we don't have that set up. But if you notice in there, so he does have he has 2.5 inch conduit up there. So now that's a 60 horsepower pump, which I I would assume that that 60 horsepower pump is going to be probably around 80 amps or so. So he's got his wires set up there, and so he's got his wires, and he's got a 2-hour fire rated wrap to go to the transfer switch, and he's got his 2 hours over there for the genset. So he's doing something right, but there's and this is important. There's a lot of code rules that goes into this, and it's important to review the NFPA 20 and the 695, and get some help on it to make sure we do this right.
No, you highlighted this one. What's the issue here? That doesn't have the 2 hour. That only has a. Wait, that's correct.
That has a 2-hour rating.
Yep.
And so you're okay with that, because you depending where that generator is, you do have to have, depending where those wires are routed, you do have to have a 2-hour rating to get over to the fire pump room. So you do have to look at that.
Excellent.
Now the other thing is you got to make sure that's an 80 kW generator, and then you got a 60 horsepower fire pump. So you need to make sure. A lot of times what I do is I send these things to the local, my local vendor for generators, to make sure that fire pump or that generator is capable of starting up the genset with no problem, within the parameters of voltage drop.
Awesome. All right, so I was watching. There's some good dialogue. Jeff Fecteau came in, and when we were talking about the transfer switch and the listing requirement, Mather pointed out there's no listing requirement. Jeff said, "Hey, don't forget that 230.66 is, it's going to require it to be a listed ATS, but that's listed as service equipment." And then he also pointed out 700 and 700.5, which I was looking at it before. 700.5 tells us that we're going to have it listed to, and that's a UL 1008, I think it is. I think somebody mentioned the UL standard. I think that's a UL 1008 listing for emergency transfer switches, but 695 is not an Article 700 system. So I can't say that I need a UL listed 1008 transfer switch for a 695 because it's not an Article 700 system. So I know it's in 700.5, and I know it has to be listed as service equipment, but there's nothing that says it has to be listed for emergency use. It says in 700.5c, it says automatic transfer switches shall be electrically operated and mechanically held. Automatic transfer shall not be permitted to be reconditioned. And then in A, it says that it has to be designed and installed to prevent the inadvertent. It says listed and marked for emergency use, but there's no equivalent. There's no equivalent. So Mather says he found in the white book that there is a category code XNVE for transfer switches for use with fire pump motor circuits, and they probably exist, but there's nothing that I can find in 695 that says it has to be listed for fire pump applications. And I could be missing it, but I don't see it, Larry. I really don't. Now it's probably that
one of the other questions that was in there is that someone mentioned, and it's true. Bruce noted that the voltage drops do not apply. So when you have the 15% voltage drop for startup of a motor, that it doesn't have to apply for genset supplied power, and that's true because there's an exception in 695. But my experience is always when you have things like that in that nature for voltage drop, and you use transformers, you always got to worry about when you put alternate sources of power with generators and transformers, that when you start and stop transformers, you got to make sure that you size your overcurrent protection to handle that inrush. So, even though you don't want to, you got to make sure your overcurrent devices are sized high enough to make sure they don't nuisance trip when you transfer power.
Yep. And the other thing, it does say that the transfer of power to the fire pump controller between the individual source and the alternate source has to take place within the pump room. So the transfer switch has to be in the pump room. That's interesting. but nothing in here says that I can find that it has to be listed for emergency use or listed for use with fire pumps. UL category code XNVE. So that's a good, I got to talk to Jeff Fecteau. Look forward to your public input.
Mhm.
That's our program. We did it in that is exactly 2 hours, Larry. That wasn't bad.
Pretty good.
That was pretty good. We were a little concerned in the beginning. I know we were like, okay, I think we got to speed up a little bit, but we had such really good dialogue in that chat box. I mean, between Mather, Jeff Fecteau, Don Gannier, Bruce, and Nihad El Sharif's in the house too. So we got a good group, and Felix, so. Is there anything we missed, guys? I don't know if we missed anything, any chat questions that I missed. I think we kept up. But if there's anything I missed from a chat perspective, from a question, please shout it out before we drop this feed. And Larry, thank you. Great job. I appreciate taking the time out. I know this is 2 hours past your bedtime. So
That's true. But no, Tom, excellent job as always. Thanks for putting this on. And really appreciate all the questions that everybody gave us. It's really educational for everybody, and we can all learn together.
Absolutely. And Bruce has been asking for this session, and I finally pulled it off, Bruce. So never give up the faith, buddy. Mr. Markov, I think it's Eli Markovic. Thanks for joining us. Thanks everybody for joining us on YouTube. I appreciate the dialogue. Please hit the thumbs up, subscribe, because we're going to have more good stuff coming up every Thursday. Every Thursday at 5 o'clock, I'm going to be online. So, and hopefully it's going to be it's going to be a different topic. So Brian Rock, thanks for sticking in there with me. We're going to be talking tomorrow about some code making panel 2 stuff. So, excellent. All right, Larry, I think our job is done here. Uh-oh. Bruce B says, Larry, your transformer calcs are the reason I sized the transformer for 600%. It always works.
There you go.
Oh, 695.4. Okay. Felix, he never disappoints. 695.4. B1A. 123. 695.4. B1A. A listed fire pump controller. A listed fire pump transfer switch. Yes. All right. We got it, Larry.
It only took Felix 2 hours to find that.
Felix, you gotta speed up, buddy. I'm sorry, I love you, but you're just a little slow on the gun. It's been 2 hours. So number of disconnecting means: a single disconnecting means associated overcurrent protective device shall be permitted to be installed between the fire pump and one of the following: a listed fire pump controller, a listed fire pump power transfer switch, a listed combination fire pump controller and power transfer switch. It is in there, and we found it, and I feel, look at that. We told Jeff Fecteau, I look forward to your public input, and he got it done. Now that's speed. Thank you, Felix, for finding that. You are the man. Awesome, Mather. I really appreciate you dialing in, buddy. Great feedback. Steve Froming, he says, good timing. He just got home and can actually chat. So he was listening. Oh, go Packers. Give me a break. Go Steelers. Right? You're a Steelers fan, right, Larry?
Absolutely.
Absolutely. See that? All right. Everybody, thanks for joining in. Please, what is the section? The section is for that listed transfer switch, 695.4. B as in Bob, connection through disconnecting means: 1, number of disconnects, A, general, and then 2, a listed fire pump power transfer switch, and 3, a listed combination fire pump controller and power transfer switch. It's buried in there. It could be more clear, but it is in there. And Mather, I would not, if I was sitting on this code panel, and I know some people who sit on this code panel, if they rejected a public input that added clarity to that fact, I think I'd smack them. What do you think, Larry?
I think so.
Yes. Awesome. All right, guys and gals and jammers, I really appreciate everybody dialing in. We're going to close up this session. 2 hours on fire pumps. Hopefully you enjoyed it. Hopefully you got something out of it. I know I did. Thank you, Larry, for your time tonight as well, buddy.
Thanks,
All right.
Tom. Take care.
Take care. We're going to sign off. All right, I'm shutting the feed down starting right now.